Hello, good morning. Uh, my name is Vinny Jindal, and I'm by education. I have done my electrical engineering, and yeah. So today the topic of discussion is projectile. So what is a projectile? This is a horizontal line, and this is a vertical line. So I just throws an object with an initial velocity of u with an angle of projection theta. So the object will goes along the inverted parabola like this. So the horizontal component velocity is going to be u cos theta, and the vertical component velocity is going to be u sin theta. This is the maximum height of the projection, h max. Okay. So along horizontally, the acceleration is going to be zero. We assume that horizontal acceleration is zero, so horizontal velocity remains constant. Horizontal velocity remains constant because acceleration is responsible for the change in velocity. So as there is no acceleration, horizontal component of velocity remains unchanged. So the gravity due to acceleration is acting downwards, and the body is being projected from O to H against the gravity. So the vertical velocity will reduces. The vertical component of velocity will reduces, and at top of the height the vertical velocity is zero. At maximum height, vertical velocity is equal to zero. So the only component of velocity that is being left over at the top of the height is horizontal velocity u cos theta. Now the when the object goes up from point of projection to the top of the height, this time period is called time of ascent, and when it goes from top of the height to the ground, this time is called time of descent. So being projectile is a symmetrical one, so the time of ascent is equal to the time of descent because projectile is symmetrical. And the total time for which the object is in the air, this time period is called time of flight. Time of flight, which is being denoted by uppercase T, capital T. So time of flight is equal to time of ascent plus time of descent. So being the time of ascent and time of descent are equal to each other, so time of flight is twice of time of ascent. So as we know that we have the three equations of uniform acceleration, v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. These are the equations of motion in uniform acceleration. Equation of motion in a uniform acceleration. So now we are going to determine the time of ascent. So we are going to take the vertical projection. So being taking the vertical projection, I'm going to use the first equation of motion, v is equal to u plus at. As I already told you, the vertical velocity at the top of the height is 0. So it is 0. Initial vertical velocity u sine theta. And it is moving against the gravity. So it is going to be minus g. And t is time of ascent. So time of ascent comes out to be equal to u sine theta divided by g. And time of flight is double of the time of ascent. So it will be twice of u sine theta divided by g. So this is how the time of flight is being derived from the projectile motion. So thank you very much, and I hope you have understood the concepts. And yeah, thank you very much.